My name is Ibukunoluwa Olowe. I'm a PhD student at the University of Texas at Arlington. And this morning I'm going to be talking about integrating non-destructive evaluation and virtual inspection data for enhanced concrete bridge deck condition assessment. So this is how I've outlined my presentation today. First, I'm going to have in the introduction, a brief literature review, the problem statement, the research questions, the plan, the tasks, and the deliverables. Currently, the United States have over 600 bridges. Of these 600,000 bridges, there are 45% are at least 50 years of age, 10 to 50% are at least 48% are between the age of 10 to 50 years, and then 7% are just less than 10 years. Of these bridges, 175 million trips are made daily across these structural deficient bridges. The Federal Highway Administration estimated that the maintenance and the rehabilitation costs for these bridges in poor condition exceed $3 trillion. And as you can see, the MBI condition rating over here, most of the bridges are over 7 and more condition rating, and then 5 to 6 is poor or fair condition, and 24% is not applicable, and 2% is in poor condition. Of the bridge, the most important component of the bridge is the bridge deck. The bridge deck deteriorates faster than every other bridge component. This is because of its direct exposure to traffic and environmental loads. Also, human hazards and natural hazards such as car crash, temperature rise, wind, earthquakes also make the bridge deck to deteriorate much more faster than any other component of the bridge deck. As you can see, this is a picture of a bridge deck that we took. There are transverse cracks, cracks at the expansion joint, concrete spalling, and exposed rebar. The deterioration of bridges, actually the main thing that causes the deterioration of bridges is corrosion. Initially, concrete acts as a protective layer to the rebars. Over time, there's carbonation and chloride ingress, and this causes deterioration formation, which eventually leads to rebar corrosion. When the rebar is corroded, it expands. This causes cracks within the concrete that eventually leads to delamination with the separation of the bridge deck itself, and eventually this leads to spalling and exposed rebar at the surface of the bridge deck. Therefore, adequate concrete cover is essential, and determining the concrete cover thickness and the rebar location is very critical in repair and maintenance. State's Department of Transportation, state DOT in the US, go through virtual inspection of every bridges in each of the states. However, this virtual inspection, it is highly subjective, and it may not detect internal defects in the early stage of deterioration. Also, some DOTs use hammer sounding. This is a process of using hammer to sound the deck to listen to the sound. However, this is also very subjective, and it depends on the inspector's experience. Some DOTs also have coring, but this process is destructive, and it only gets spot measurement at random locations. To address these issues, non-destructive evaluation techniques has been used in the past. There are several non-destructive evaluation techniques that are used for several purposes. These are just a list of them. We have the acoustic emission, which is used for cracks in the void. We have the ground penetrating radar, the ISL potential, the impact echo, the ultrasonic pulse wave. All those are used for delaminations. In my research, we're going to be using ground penetrating radar and impact echo. This is because there has been several studies in the past that has validated that amongst all this non-destructive evaluation, several of them that detect several other things, these two are like the most gives the most accuracy. They have the most reliability. They are faster. So in our research, we're going to be using GPR and impact echo. Also, past studies have also used this GPR successfully. For example, Azan and Yazdani, they developed a GPR contour map for a bridge deck system, and this contour map was able to give the internal condition of the bridge across the defects. This contour map was used for a newly constructed bridge deck that shows signs of distress, internal distress, and the GPR system was successful in determining the internal condition of the bridge. Like I mentioned, there are many non-destructive evaluation techniques. However, interpreting these results from the non-destructive evaluation techniques has been a thing of issue. And a lot of people have tried to propose a method to describe the results from the non-destructive evaluation techniques so that average bridge owners can be able to understand what these results means. Because from the previous slides, you can see contour maps. Most of these non-destructive evaluation are being presented as contour maps. And because each of the non-destructive evaluation is evaluating a different thing. For example, GPR evaluates corrosion, while Impractical evaluates delamination. So there has been advancement and studies has been carried out to try to interpret these results in a better way, in a way that is understandable. For example, like the MBI condition rating, where it has a script number, and just by seeing that number, you know what the condition of the bridge deck is. And this is what Dean tried to do. In 2015, he developed a bridge deck corrosive index using what is called the fuzzy set theory. The fuzzy set theory is a branch of artificial intelligence, but it's not a black box. What it does is that it takes into account the experts' opinions, it takes into account the vagueness. So what he did in his research is that so this over here is the result from a GPR condition system. He tried to use that to develop a fuzzy set system that was able to change the results from the GPR system into developing what he called the bridge deck corrosive index. As you can see over there, you had category B, which means it's slightly on LD deck and that information is not yet necessary. So given these results, bridge owners and DOTs would be able to see the exact condition of the bridge. To further develop on this, Gagarin also developed another bridge deck condition rating approach using fuzzy sets. Fuzzy sets takes into rules, takes into expert opinion. So it's not just a machine learning process that learns. What it tries to do is that it learns human reasoning. So what they have done is that they put experts' result into the system and then use it together with the GPR result to develop a CRIPS number, a condition rating number. So I'm also going to be using the fuzzy set theory. So the problem statement is that currently bridge condition ratings are primarily based on MBI ratings, and these use virtual inspections. Also, when multiple NDE methods are performed on a structure such as the GPR and the Impractical, the results of these methods are presented separately. For someone who does not understand how to interpret these results, it might be conflicting for that. And then existing condition rating does not include NDE data. From a survey that was conducted by Federal Highway Administration, 10 states DOTs were consulted and they were asked how they use the NDE data. Even though the NDE data is a very valuable data because it gives you the condition of the bridge deck even before the external deterioration shows, many of the DOTs said they only use these and they only use the NDI, but they don't incorporate that into their condition rating system. Also, there's an absence of a unified approach that combines both the results of multiple NDE methods and virtual inspection. Like I mentioned, Dean and Gagarin, they did a lot of research and tried to have a number from the GPR ratings, but their research only considered GPR, which is only the corrosion aspect. The internal delamination within the structure was not considered. Other type of defect that could be within the structure, such as cracks, voids, it wasn't considered. And these are the research questions. First of all, to what extent do current practices incorporate NDE data, and what are the limitations of not doing so? How can GPR and impractical data be effectively combined to give a detailed understanding of subsurface defects in bridge deck? How do experts' opinion influence the weighting of various defects in a fuzzy-based condition assessment? And how can fuzzy logic be applied to develop a condition rating system that combines GPR and impractical together with virtual inspection for a good condition rating? And this is the research plan. We did an extensive literature review to understand what is being done, what is being used. We also did data collection. I'm going to be talking briefly about each of these: data analysis, correlation between the NDE data, developing the condition rating model, expert survey, journal paper writing, and dissertation writing. So in the data collection process, what we did is to collect a full-scale scanning of 10 concrete bridge decks in Texas. We used the GPR data and the impractical data. We got the internal condition of these bridges, 10 different bridges within Texas, and these bridges had a wide range of applicability between age. We had a bridge that we collected the data. The bridge had defects as much as so much rebar. The rebar shadowing was very visible in the first 10 days of the construction. We also had a bridge deck that was over 75 years of age. So it was like a wide range of applicability of data. And from the data of this bridge deck, we had GPR data that was more than 4,000 data points. From each of this bridge deck, we have the rebar cover, the corrosion, the delamination, and these tests were actually performed on the deck surface. We had longitudinal grid lines of spacing of 2.5 feet drawn on the deck surface, and over there is a truck-mounted GPR system. So for some bridges, because of the heavy traffic, and we did not want so much traffic closure, we had the GPR system attached to the truck and then drive the truck at 5 mph across the bridge deck. So this is also the impractical data collection. We also did that. So I'm just going to be going fast. And then we did the GPR data analysis to get the hyperbolas from the GPR, to get the top rebar cover, the depth of the top rebar cover of the brick, and also the impractical data analysis. And this is the main step of the condition rating system. It's a system that takes into account the defects from both the impractical, the virtual inspection. We also did a survey. We gathered over 100 bridge inspection results to determine what are the most prominent defects in bridges. So bridges that are rated poor or fair, we try to see what are the most prominent defects in these bridges. Why are the bridge inspectors rating it poor? Why are they rating it fair? All these were put into consideration, and all this data was gathered, and that is what we used in this integrated condition rating system. Also, we did an expert survey. The purpose of the expert survey is to get the opinions, we want this survey not just to be a black box where you just put it in and you don't know what's going on. We wanted to get the real opinion of experts, how they're using the NDE data. Then also what we did is that we gave the bridge deck that we had from our inspections, we gave each of these inspectors. The expert survey was conducted across the 50 states of the United States from several DOTs. So we got different responses from different bridge inspectors, different DOTs. All these informations were gathered into our fuzzy logic model system, and all these would be used to develop our integrated condition rating system. So at the end of it all, we had like detailed findings from each of the NDE, from each of the bridges, a model that takes into account the NDE data and the virtual inspection data as input variables and generate just one condition rating as an output. Also a guideline explaining how this model was developed, the inputs, the outputs, and the limitations, and also results from the expert survey, including their responses, the analysis, and also we have been having conference presentation, journal papers, and dissertation. Thank you very much.